Okay. Hello. Okay. And now let's go back to our discussion. Okay, so SQL. It's all about SQL now. We're gonna focus on SQL. So what we're trying to do is do these things, explore different kinds of relationships, which is super duper important to understand the relationships between tables. Acquire language that describes those relationships, which is SQL, that's the language, and understand how to structure a database in reasonable and efficient way, and this is called data modeling. And then we discover how to build SQL queries to find the related information in a database. See how to write these SQL. So what's a schema? As we said in the morning, it's just a table. So it's a schema, it's a representation for your data. Exactly. So it's a description, the way that data is organized in a database, and the relations between them. Yeah. So what's, for example, if we're talking about a table of student, student has some data. Each student has first name, last name, ID, whatever, address, GPA, and so on. So this data need to be addressed in a specific way, and this is called schema. And the example that I think you are working on, you will see, so this is, think of this as a school, and we have students, we have some classes that people will take, and each class has a teacher. Okay, think of it this way. So we only want to see what classes you are taking and what you are teaching classes. So let's say you are a teacher and you are a student, and there's some classes you're taking and he's teaching, and someone else teaching and someone is taking, and so on. So this data needs to be represented in a specific way using schemas or tables. We call them also entities. So the schema is a table, or in this case, a set of tables. So this is called schema. But the specific one is called entity. Or people won't use these terms in the future. They will tell you, okay, data model, which is a schema, and they call them tables. No one calls it schema or entity, but some people do. So tables are entities. Each table is an entity. So these are entities, teachers, classes, and students. And I will see what that means. We'll see, gonna go through this and then I'll stop and tell you. So each entity contains one or more fields. So for example, teacher include name of the teacher, department where this teacher worked for, and the classes that this teacher is taking. By the way, this is not a table yet, but we're just trying to build it. So this is the data. When we start up, that's the data we want to represent. Each teacher, name, teacher, department where this teacher worked for, and the class that he or she is taking. Now classes, I want the name of the class, the room number, and who is giving this class, and who are the students attending this class. For the students, I need to know the email, the name and email, and I need to know what classes the students is taking. Okay? So I need to keep this data. We will not end up with this design. It's going to be different. But think of NoSQL in the morning. We wanted different ways to represent the data. We wanted all the messages from this room, and we wanted all the messages from this person, the user, right? So here's the same. We need to know all the classes that are taken by this student. We need to know all the classes taught by this teacher, and so on. Okay? So different ways to represent the data. So example of that, this is Cynthia, teacher. She is from music department and she's teaching 2 classes. We call this a record. It's going to be actually a set of records, but let's think of each piece of data as a record. which is the one record is Cynthia from music department teaching music theory. That's one record. Another record is Cynthia from music department teaching brass method. I know what brass method is. Okay, so this is a record, entity and the record. Can you describe relationships between these three tables? Now, this is something new to you. It's very important to understand at the beginning. You want to answer? Please. Aha, cool. So you have some background in it. Good.
Each teacher has many students.
Has many students. Cool. It's very important when you design your schema to understand the relationship between the tables. I mean, this is something not in the slide, but relationships in databases are three types. One, we call one, two, many. Two, there is many. Two, many. Well, many to one is one to many. It's just how
Isn't the relationship you reveal like each entity inside each entity?
Exactly.
The teacher is inside it, there's a class. The class is inside it, there's a teacher and students.
Yeah. Well, that's going to be the end result for sure.
That's almost the same relationship.
Well, for this example, yes, so we're going to build one relationship, it's going to be forever. 3, 1 to 1. Very important. This is rare. It's rare. You won't find this a lot. This is a lot. And this is also very popular. Okay? But focus is here. People don't focus here because this is a special case and people handle it differently. So let's see what that means. Okay, let's take this example. So when you design this, first you think, what are the relationships between these three tables? So, as a student, I take classes, right? And they have teachers. But teachers, they teach these classes. There's no direct relationship between me and the teachers. So I take classes. How many classes I can take? A lot, many, right? So as a student, I can take many classes. So that's a one-to-many relationship. It's one-to-many. As a teacher, I can teach many classes. So you interact with the classes directly. You don't interact with teachers. Okay?
That's also one to many.
That's also one-to-many. Okay? But each class, how many teachers they teach the class?
One.
Just one teacher. Okay? That's the assumption. How many students in the class? Many. So how many students in one class? Many. How many classes a student can take? Many. That's not one to many, right? It's many to many.
But the teacher to student.
Teacher to student is, well, in this case, there's no relation, and I will tell you why later. Okay. So that will describe the teacher.
Teachers can teach many classes.
No, look at one teacher. They can teach many classes. Look at one class. It can be taught only one teacher at a time. That's our assumption. Well, the case could be different in schools, but in our school, that's the assumption. Okay? It's just like having very small schools. Okay, we revisit the relationship involved. So in this case, that's the relationship. Each class teaching many students, many classes. Each teacher teaches many classes. Each class will be taught by only one teacher. That's why you have this one and infinity. Again, this is important also to understand. There's two tables here, right? They represent this relationship in many ways. So this is the many and this is the one, right? Some people do it this way. That's the many and that's the one. Some people do it this way. And that's the one, that's the many. It's kind of confusing, right? So you might see it this way, you might see it this way. Be careful. So some people, they put this and they put one and infinity. So you can use whatever you want. These are the most popular two. Okay? This is part of something called UML, which is a language that describes relations. Okay? We use this. So this means one. It's weird, I know. But I like this way. It's many, one. One and many. So it's always many here and one here. Yeah, the way you see it. Okay, let's go back. So easy, a relationship between a class and teacher. It's just one to many. Now, how do you represent the data? Again, we want to know this teacher, what classes this teacher teach, and this class by what teacher is taught, right? So, when we ask classes taught by this teacher, do you expect to get one record or array of records?
Depends on the teacher.
So array of records. Could be 0, could be infinity, right? But when we ask like teacher of the class, do you expect an array or one?
One.
One. Okay, cool. So now the question we should ask ourselves, we have these two tables. How do we connect tables together in databases?
By the ID.
By kind of ID. Okay, so we have two ways. You want to say, we need two things. We need to say what classes this teacher is taking. Who is the teacher for this class? We need to answer both questions. So we either say, okay, classes, here's the list of classes taught by this teacher. Here's the list of classes using their IDs taught by this teacher, and so on. Or we say, this is the ID of the teacher who's teaching this class. What do you think is better? Yes, sir. Huh? And what? Primary, yeah, I mean, this is called primary, I'm gonna get to it. But like, do you think we should set the data here or there?
Can you repeat the question?
Okay, so in order to connect these tables together, okay, we can save the IDs of the classes taught by this teacher. So this teacher is teaching classes, right? We need to say what classes they are teaching. So we can put, he's teaching CS 1-on-1, so we put 1 here. He's teaching 2, 4, 5, so we put 4, 7, for example.
Okay.
And for the second Sebastian, teaching 2 and 6.
Okay.
And Kelly is teaching 5. That's one way. The other way is, we just put the teacher ID here.
I have that.
Well, let's go back to Yazan. What do you think, Yazan?
I think the teacher ID is better because you will not reduce it. You will not repeat it again.
Cool. Yeah, because this is unique and will not repeat it again. And how many, there's good benefit of that. You put only one piece of data in one location. It's not a list, right?
I was going to say with the ID in the classes because each class has one teacher.
Exactly. Each class has one teacher, so put one piece of data again. Cool.
So both ways work.
Both ways. I mean, your way and his way is the same. You put the ID of the teacher in the class.
I have another opinion.
Yeah.
My opinion is to do both ways.
Both ways. Why?
Because I need to search in a different way. It depends on how you want to search.
Cool. So
You
you,
need both ways.
this way or that way. That's good opinion. Anyone else?
What man is done. Here you will have one element have many elements. Right?
Yeah.
Yeah,
Many classes here.
many classes. There we have one teacher have many classes.
No, one class.
One class,
One
have
teacher.
one teacher.
Yes.
That will reach the teacher as easier than this, right?
It's easier.
Faster. But here the length will be less.
Ah, interesting point. So what he said is, Mu'tasim said, well here we need to put a list. Can array, right? Here we just put one piece of data. So if we don't do this, and we just put an array here, we need to do some kind of search. It's going to be big complexity, which is a valid point. So we can do this. Put for example, the names of the classes, their IDs, whatever. Okay, and this is an array. That's going to be from all put their IDs. We just put their IDs. These are the IDs, and each one of this is a list. And we know about SQL database. It's a table and it's hashed, and each record includes only one piece of data. So that's not possible. Which then we go and when this gets bigger and bigger and bigger, it's going to be big lists. So every time you need to update this list.
This is like the thing that we talked about.
Yeah,
The message.
exactly.
The same thing, you get the idea and put it in a list.
Yeah,
But in here, we have to do something else.
yeah.
It's a table.
Because every record in SQL, that's what's special about SQL. Every record gives you only one piece of data, and it's easy to index them. So that's why we have another choice, which is putting the class IDs here and duplicate this. So Morgan teach this class, Morgan also teach this class, and so on and so on and so on.
But the other way is
There's a problem here. I mean, that works, but what's the problem here? We're repeating what?
The classes and the teacher.
I mean, we don't repeat the classes.
the department.
I mean, department, every teacher has a department, so which is fine. But we're repeating teachers here. What's the problem with that? We're giving the same teacher two IDs. Who? So the ID of Morgan here is 1, the ID of Morgan here is 2. That's confusing. So we lost something important, which is
A unique identity.
everyone has a unique ID. And we also lost something else. Something called, I'm sure you guys don't know this term, but keep it in your mind, put it in a note on the side. Something called normalization, data normalization, which is each piece of data lives in only one place in that table.
Yeah, on the board.
Normalization. I'm not going to write the definition.
Yeah, just put it on.
Normalization. Data normalization.
Isn't it the same? Even if we do it with the other
Yeah.
the teacher is here and give one ID to the first class and the same teacher ID to the other classes.
It's the
Just
same.
unique.
I mean, if you do it in there, but if you do it in here, that's not going to work. And there's another problem, which is what if you want to change the department, or this is, let's say, last name of Morgan. Morgan, he or she, I'm not sure. He, right? Change his last name. What are you going to do? Are you going to just go to one record or do many records? Many records. Because Morgan is duplicated. So this is not a valid choice. The other way is to put teacher ID next to each class, and that should work fine. Now ask questions. Ask, hey teacher Morgan, what classes you are teaching?
I will give you physics 101.
How do you know that? You go to each class there and find that if the teacher ID match Morgan ID, you solve the problem. Hey class, who's your teacher?
Morgan.
1, and you ask this table who's 1, it will tell you it's Morgan. So, what's the relationship between teacher and class?
One teacher for many classes.
One too many. One too many. Is it one too many or one too many?
Yeah, one.
One too many, yes. So one too many. Where, okay, let's pause on this. FYI, the unique ID for each record called primary key. The primary key is a unique identifier for each record in the table. Now, in order to connect this table with this table, we keep the primary keys of this table inside the other table to make the relationship, right? As you see here. So, each one of these has a key, and this is called the primary key. What is the primary key for this? Classes. The IDs here, right? And they are unique. Very important to understand they're unique. Now, at the same time, in order to connect this with that, you need to keep these IDs somewhere here, which is the teacher ID. And this is called a foreign key. Foreign. Is it like this? Foreign key. Foreign key. And is it unique?
Yes.
It's not unique.
It's not unique. It's fine. Primary key is always unique. Foreign keys is not unique. Not necessary to be unique. Now, in order to connect the two tables together, you keep the primary keys in the other table key column, in one of the columns of the other table. And that will make the relationship automatically. Get the point? Should I say this again? Okay. So before we have these, forget about these. Let's imagine they're not there. So in order to connect this table with this table, and like each class should have information about the teacher who's teaching this class, you need to add the ID of the teacher who's teaching this class to the record. So we create a new column called teacher ID, and this is the ID. This will include the ID of the teacher who's teaching this class. Okay? When we say 3 is unique in this side. So we know it's Kelly. When we say 1, we know it's Morgan, and so on. Okay? The unique ID for this table and this table called the primary key, and the ID that comes from the other table to make the relationship is called foreign key. Primary key should be unique, foreign key it's okay not to be unique. And that will make one-to-many relationship. Where do we save the foreign keys? Is it on the one side or the many side? Always. This is a rule. Don't forget it. If you want to make a one-to-many relationship, you need to save the foreign keys. You need to save the primary keys of the one table on the many side on the foreign key column. That's a rule. Don't forget it. Some people are asleep. Can anyone sing for us or something? Yeah, please.
It's actually a bit confusing, so I'm going to ask it. Okay?
Ask it.
The first example that you gave us was a bad solution for the tables, for the schema.
This one.
Which is, giving the teacher the schema a new column, which is a class ID, and giving it inside each class an array.
Right.
Okay? In the end, you said that we have to give the ID, the teacher's ID, inside a new column in that classes, right? But what if the same teacher gives gives more than one, let's say,
Classes.
class?
Yeah.
Okay.
Like in this case.
It will be an array as well.
Yeah. We'll get an array.
We'll get an array. So
But you cannot save an array inside one record. That was the problem. So in this case, you cannot save an array here of values. It's equal. So you should, every record should have only one piece of data, not a lot of data. And this one has more than one piece of data in each record.
Okay, but
So each record should have one piece of data.
okay, which is an array.
But this one has many data. Like this says Morgan works for psychology department. Teach this class. Morgan works in psychology department. Teach this class. Morgan teach this class. So this is many pieces of data. And this is not SQL. SQL should have one piece of data in order to make it good complexity. But when you query, when you tell me, give me a list of classes that Morgan is teaching, we're going to take this ID, search here, which is this and this, you get a list of classes.
So that
Which is
teacher
fine.
ID will be one element in each class.
Yes,
Oh,
always.
What if two teachers teach the same class?
Well, good question. And this is not our assumption. If that's our assumption, this is going to be not one-to-many relationship. It's going to be many-to-many. As in the next example. I'll show you. Okay, so we know now it's one-to-many. Now let's think of students. Students can take many classes, and each class has many students. So it's a many-to-many relationship. Now, in one-to-many, we save the foreign key in the many side. How about many-to-many?
on each side there is an element.
So we could put a foreign key here and a foreign key there, right? That's cool. Yeah, let's try it. So it's a list, right? And we cannot split them because, I mean, class CS111 will have 4 students, so we're going to have 4 records? No, that's against SQL. And we cannot have a list that's against SQL. Can we do it in the other side? Problem, the same problem.
What's the problem?
What's the problem? This is many and this is many. We need to put the foreign key somewhere.
We put them in students because
Well, it's, yeah, this is student. So Tay or Ty,
one
is
is
taking 2 classes.
okay.
That's the problem. That's against SQL. SQL, you can have only one piece of data in one row. Same. We make a new table for what? For the matching process.
Like many.
That's
One
cool.
to many.
Exactly. Whoa, you guys are smart. So they said, Hamid Hussein and Basma, I was about to tell you to call you Balqis. I didn't know where I got that.
This is nice.
Well, they said, what if we create something, a new table, that will just do matching? To match this with that. So whenever there is a class taken by a specific student, we create a record. And this is exactly the solution. Cool, good job. So we cannot even do that because every class is taken by different students and every student has many classes. So in this case, we need a matching table that will match people together, student with classes. And this is called middle table. Middle table, this is a well-known, this is, they will, in interviews, they will give you a question, something like that. Tell me like, can you write a data model for this problem? A data model. So this is what we're doing now. We're doing data modeling. We're designing. We're doing the architecture of the system. So we're building the school. We need to do the backend, and we need to build a database. In order to build a database, we need to know what that means. Data modeling. That's what we're doing. So that's a one-to-many relation. One-to-many to the middle table, and one-to-many to the middle table. If you want to build a many-to-many relationship
You have to make a middle table.
You want to make a middle table, and the money side is toward the middle table. That's also a rule. So now what does this say? Class 1 is taken by student 1. Class 1 is taken by student 2. Class 2 is taken by student 4, and so on and so on and so on. How do we know how many classes CS, let's say, CS 245 taking by? Give me the list of students for CS 245.
3 and 5.
How do you do that?
Which is
Is it 1 or 2 or 3 steps?
It's going to be 3 steps.
3 steps, 2. Okay. It's more than 1, right?
More than one.
Okay. So what do you need to find first?
Class ID.
So that's the class ID for, and what do you do with that?
You go to the middle table.
You go to the middle table.
Exactly how many.
3 and 5.
There's 2
How
here.
many class ID?
You need to go to those ideas in chat.
Yeah. So if you see the matches, there's 3 and 5, and you get them from here. So Rebecca and Albert.
And you need to take care of that.
And you need to tell that. Get the point? It's, I mean, when you write SQL, it's different. But you need to imagine the idea. If you don't get the idea of the one-to-many and many-to-many, you cannot type SQL. You will type it, but you will not understand it. You just type. Okay?
In the middle table, what's considered the primary key and what's considered the foreign key?
They both are foreign keys. There should be an extra primary key. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Yeah, this is missing one. Each table has a primary key column. That's not negotiable. Okay? So that's our demo model. Final. One-to-many. Every teacher takes many classes. Every class has many students. Every student's taking many classes because there's a many table. This is useless. Does not have data at all. It's just to match. Okay? Some of them, they also have data. What data we can add to every record here? Think of it. So we said this middle table, let's go back. It will match a student with a class, right?
It doesn't have any.
What data we can add like another column to make it useless, to make it useful? Well, name of students is there, we don't need to do that. The room number is here, we don't need to do that. But something that's not there yet. Well, that could be here, like in classes.
Teacher.
I can put the number of students.
Teacher.
Well, the teacher is here. Something that connects a student with a class. Something new.
Number?
Here, time. Time is the class has time, so it's not for specific people. Something specific to student with a class.
The room?
The grade.
The what?
The grade. What's their grade, right? Like how much they got in this class. We can add this to the middle table because it's already there. We should take advantage of it, right? And so on. So the main idea is to match, but you still can use it to add data to it. Got the point? No, like the room number is here. Like you can add to the class. Room is the room number. Ask yourself, is room number something specific to a student of the class or something specific to class itself? The class. So it's generic for anyone in the class. But if you need to add something specific for that student in that specific class, you add it to the middle table. No, the primary, there's an ID. 1, 2, 3, 4, 5, 6, 7, and so on. So these are 2 foreign keys.
And then
There is a primary key here, and whatever data you want to add. Okay? Whew. Now, the rest of this lecture, I'm gonna try my best to write with you a couple of things. Maybe live coding. Well, this is water. Okay. So next thing is, let's say you already built these. They're built for you. They are saved somewhere. Okay? So you see these? There is a way in MySQL or in SQLite or any database management system to build this schema and save it in a file that the extension is .db. Do you see that in school? Like there's school in the repo, .db. So this is the database file that can be read by SQLite or MySQL or any RDBMS, okay? That has all of this schema. It's already there. And it gives you actually some interface to deal with it. Tells you, okay, if you want to show the tables, you just put dot in the command line, dot table, and you hit enter, it will show you all the tables inside the schema. I'm going to show you here. So, yeah, I can use my terminal. So if you do dot table, I'm inside SQL. Let me exit actually first. So I'm inside just my desktop, PWD. I'm inside my user desktop and inside your exercise, RBK 6 school. And I can do ls, and I can do SQLite and the name of the database. I have this database file. It has all of my schema. And SQLite 3, it's a SQLite, RDBMS, okay? This gives me an interface to interact with my database that's in this file. So what I do, I just run this command, and it will take me inside my database. Now, I will ask, what do I have here? Let me just clear. What do I have? Dot table. If I do this, it will tell me, well, you have 4 tables. Classes, departments, teachers, classes, students. This is the middle table. And students. Departments, something else. Right? We did not take it here. There's many things like, could be other tables. These are the 5 tables we have. Now, I have the ability to use SQL here. Okay. A well-known command, select. If you want to see what's inside your table, you can do, I want to select all rows inside from this keyword. Select from its keyword. Star means all, and the name of the table, and semicolon at the end.
Rows or rows?
Yeah, everything.
Everything. So rows.
Give me all rows, and all columns. It's actually select the column, not the rows. Rows is something else. Give me all columns and all rows. You don't need this, by the way. Write this down. It's okay. It's already there in your exercise. I'm just show you something, some example. Okay. From is a keyword. Class is the name of the table, and semicolon, and hit enter. It will tell you I have 4 classes, JavaScript. I don't know what that is, but in the slides it will tell you. Let me show you something. Describe. So you can. Well, I got these, but what does that mean? What's one? What's JavaScript? What's one? What's one? Okay, you want to do describe. So describe. Yeah. Well, it's conventional. It's not case sensitive. SQL is not case sensitive, okay? But it's conventional that we use what? Syntax error. Is it? Yeah, describe. Seriously? Oh, what's going on here? Seriously? Yeah, because the example used MySQL. Okay, how do we fix that? Did you watch NBC Must yesterday? Who watched it? No one? Seriously? Well, it's literally watch NBC Must for 30 seconds, 30 minutes. Okay, it's the only station on TV that gives you advertisements. You know, they love advertisements for everything. But what's weird about the advertisements, every 5 minutes, they share advertisement about like conversation between two people, and some like there is someone who's having a computer and just listening to other people. Other people like, do you know who's, let's say it in Arabic, uh, like a woman is getting her child to the coach and like, why my child is not playing football? And he's like, لأنه بيشبه تريزيجيه. Looks like Trezeguet. And someone asked like, who's Trezeguet? And the coach said that's like means three in Latino. Trezeguet is a player actually. And the guy who's sitting on the computer just like opened Google and typed like, who's Trezeguet? And shows you the result. Okay? So they're advertising for searching on Google. So everything you hear, you should go to Google and Google it. That was the point, but you guys did not do it. Okay. And that's what I'm gonna do now, actually. I'm gonna do.
MySQL versus SQL Live.
I thought RBK is putting advertisement on this.
No! I'm gonna do like how to describe on Google on SQLite. No, don't go. Don't go. We're not done yet. Schema.
What did you search about? How to
Describe in SQLite. Schema classes. Yeah, I mean it's not fancy, but tell you, we have an ID, it's integer, and then we have the name of the class, and you have the department, which is an integer, it's a foreign key. Here's the foreign keys. So you have department and teacher, they're both IDs, they're integers. And I'll tell you, well, department is a foreign key from the table that's called departments, which refers to the column ID, which is the primary key. And then we have another foreign key for teacher that comes from the table teachers that refers to the ID there. You don't need to know this, it's okay. Just trying to understand. Okay? So you want to select everything from classes. So JavaScript class has ID1 and it's in this department, and what's the last one? Teacher. They're doing taught by this teacher and so on. Now this will give you a portal. I want you guys to try it on your own. But I want to like show you some stuff really quick before we go. It's very important to focus on the last part. Get some energy. You want to wake up for like, okay.
should we see any people?
Yeah, you should see.
The files? Where?
Yeah, you have access. You have access to them here
Yeah, but I mean in the file.
in the file. Yeah, I mean if you can do describe, it will give you the way it's written. This is how it's written. This is the actual language.
If you go to the school.db, you're gonna see weird stuff.
Amazing. Yeah, let's do that actually. So she is saying, what if I go to here and open this something weird thing? Open with text. Look, it's all
That's encrypted or something?
like foreign keys, class integer, whatever, create table. And there's weird stuff. I don't know what it is, but it is. Yeah, open from the terminals, but looks better. All right.
Is that how usually you interact with the databases? You
Yes.
do it with the terminal?
Yep. Well, SQL Server, they have their own
Interface?
SSMS. SSMS is a user interface for databases, for their own databases. Okay, I'm gonna keep this short. Okay, last thing. Is it here or here or here? No, no. Okay. Okay, last thing. So this is how you see the schema. This is how you select everything. Now you can select star means all, but you can select stuff. Like I don't want to select everything. I want to select only name. Just give me names of the classes. So it will give you just a list of names of the classes. Give me the ID of the class. Just give me a list of IDs. Give me the ID and the name only. So ID, comma, name. Just give me the ID and the name next to it. Yeah. Yeah, I mean these are the classes. Name of the class is JavaScript. Name of the class is communication. Okay? And this is its unique ID, it's the primary ID, and so on. Okay? You can select whatever column you need. Okay? Now, so you choose what you select, and also you can apply conditions. What if I want to apply an if statement on the selection? So whatever you put after the select, you specify what columns you need. But what if I want to filter the data? I only want data. I only want classes with this for this specific teacher, for example, where teacher ID equal blah.
Okay.
So you filter out data, and this is where you use where. So select these from classes table. Where is the keyword here? Where teacher ID equal blah blah. Let's go back to our schema. So this is the schema, right? Yeah, I mean you can do where teacher actually, not teacher ID, equal 1. It tells you 1. Let's put 2. Let me see what we get. Communication.
This is giving us the idea of class.
No, it's not. But they made the data this way.
It's a coincidence. We can do
Nothing.
scroll up and see what.
Yeah, I mean you can select everything if you need. Go up. These are the classes. Yeah, the problem is the teacher ID match exactly. D. Okay, what's this? Department?
Yeah.
Okay.
Yeah.
Select where department equal 2. So there is 2 courses, 2 classes in this department. So this is an if statement, kind of. So where is an if statement, okay? Constant time for each piece of data, yes. And so on. Now, there's other things. There's many tools there. It's big language, okay? So you can give each table an alias. So if the table name is big, you can give it just one letter name. Alias. You know what alias is?
Yeah, another name.
Alias like a shortcut. Like if you want to say, I don't want to keep typing classes, just want to use, I want to give it a name, C. So C means classes. And then you can use C dot there. So why do we have this? So let me explain this from the other side. So let's say there's 2 tables, and the 2 tables have names. The 2 tables have columns name. This has name, this has name. Department has a name. And the class has a name, right? So if you say select name from department and another table, which one will get you? It's confusing, right? So you want to say, I want to get department dot name and class dot name. You want to specify. And instead of just doing department dot, you see dot, D dot, or C dot, and so on. I'll show you where do we use this. Here. Let me show you something. We're not getting that right. Anyways. Okay. So let's say you gave classes C, so C dot name, C dot room, where C dot teacher ID equal 1. So you're accessing one table. Now, I know it's confusing, huh?
C means that you define C as class.
Yeah, I mean C, think of C as it's exactly match classes. C is classes, means classes.
Why do you need it?
Why do you need it?
Here.
Why in this example you don't need it, but this is going to be introduction to others.
Suppose you
Like
need
if
the
we
same.
have the same name, we have the same key, or I don't know, the name, more than one table, we have to specify where to get the name from.
Exactly. But this is just an alias for it. It's just another nickname.
So you just won't write classes.name, classes.name.
You just put C dot. Wake up, guys! Come on. I know it's a long lecture, but it's very important. I don't want you to miss any piece of data here.
Are we gonna have a third one?
A what?
A third one.
There's but no.
No, that's it. Yeah.
We're searching, we're adding. Are we going to create a table?
Well, yes, at some point you will learn that, but not now. Just learn this for now. Yeah. Safe. Just like if you do this, you're doing great. Like maybe, but it's in the files. We already wrote it for you. Cool. Okay. Now, okay. What else? Now, this is cool. Okay. So I want to say, I want to know who are the classes for this specific teacher ID. What if I don't know the teacher ID? I want to say, give me the classes for this teacher name. But does C dot teacher ID is take an ID or a name? Or we have only the name. So we want to say, give me this with the teacher ID equal, and here I need to write a query. Say, give me the ID of this specific teacher and pass it to the equal. You always do that using JavaScript, right? And this is how we do it here.
Another select.
So another select inside the after the equal sign. It's like for the ID Sebastian, give me the ID of Sebastian, and between the parentheses, and the parentheses will result with one number, which is the ID, and pass it through, so we get the class of Sebastian. So nested, could be nested, could be bigger and bigger. Okay? That's not only. You can do that also. Whatever you did here, let's go back to the previous question. So, give me the name and the room from classes where the teacher ID equal to. This can be done using something called inner join. That's also another way to do it. Inner join. That's also keyword from SQL. It's part of the language. What does it say? It says, okay, join the two tables together, mix them, using the foreign key, and then write a query on them. Let's see how that works. So, what are we joining? Forget about the select statement. So, classes, give it an MC, inner join teachers. So we're joining the two tables together. Okay? On how do you join them? the teacher ID should match T dot ID. Go back to the tables here. It's not, this is not easy. Learning a new language, remember. Okay. Classes ID, what was the last one?
Teacher ID.
Teacher ID, okay. So for this teacher ID, I want you to join the data together. So the data of the classes and the data of the teacher. Let's see an example. So let's say classes. So this is a classes. Classes has an ID, has a name, has teacher ID, right? That's one table. The other table is teachers. Has an ID, okay, has a name, it has other data, whatever, right? So this is a foreign key, FK, foreign key, okay? So, class 1 to 3, name is JavaScript, Python, and C++, 3 classes here, all programming. Teacher ID, teacher 1, and teacher 7. So teacher 1 name is Jacob. No, Ahmed does not like, likes Python. Okay. And somewhere 7, Joseph, teach C++. Okay? So this is, if we merge them, if we inner join them, what will we end up with? Let's say we have, this is 2, let's make it simpler, 2. Okay? Not 7.
Remove the ID and put the name.
Kind of, yes. What? So can I put like age? Joseph 60. Jason 17. So before we do any select, when we join them, inner join, we'll end up with this. Look, it's gonna be the data. Classes dot ID. Classes dot name. Forget about that. Let's say C dot. See, it's easier. C dot teacher ID. And then T dot ID. T dot name. And then T dot age. You will get a big table like this. You'll say 1 JavaScript taught by teacher ID Jacob, who's 17 years old. And now you get a big table. You can select statement. And then you do 2 is Python taught by teacher 1 Jacob, 17. And then you do 3 C++ taught by 2 Joseph, who's 60. But the good news is, since the whole purpose of this is to match, you won't get these. You'll just get the actual data you need. So we get, this is the class ID, the name of it, and who's teaching, and what's their age. That's it. And you can apply select statement. But remember, when you select, you need to specify C.name or T.name in order to show the data. That's after you join. And this is what we achieve by using inner join. Very important, otherwise give you an error, which is the on. Because see, it's a, so you're joining classes C with teachers T, you're inner joining them on how, on means how to join them.
The premise of joining.
It it should like we should mention here what's the name of the foreign key and here what's the name of the primary key. And you can give a condition if you want. This is optional. The select statement here is optional, whatever you want to put here. You can put star here. So you have all freedom you have all these tools. You can play with them, use them together. Try things. You guys should try, keep trying. I mean, that's how you learn SQL. I don't want to spend more time. I think you guys should try it on your own. All the rest is the same concept. It's very, what was important to me is you guys understand domain data modeling. How do we create the tables? What does the relationship mean? How to create the relationship? And that's it. Rest of it is just like how to do select statement, how to join things together. Let's see also, you can join and use where statements. There is different types of joining too. You can inner join twice. So you see this one? This is the result, right? You can inner join it with something else outside and give you a bigger one, and so on and so on. So you're going to combine all the data together, and you just query, you just select statement in this big table. So this is a big one here. So let's go through this really quick. Don't look at select first. Leave it to the end. Always look at from. Where are we getting the data from? It's classes. Inner join classes students. Can anyone remind me what class students is? The middle table. So classes with the classes students. So what does the class students give you?
Parent ID and the class ID.
Yeah, so whatever the class is, what are the IDs of students inside that class? So you're joining them together. This will give you a big table of each class and the ID of the student who's taking this class. And the same class and the second student who's taking this class. Just the ID. And how do we reach the name of the students? You inner join that with the student table again. So you do two inner joins in order to get there. So we join first. We join classes with classes students. We get the matching IDs, and then you join the result of that with students on C.student ID equal S.ID, and you inner join that with the teachers to get the teachers for these classes as well. So you get a big table of like, what's the name of the class, data about the class, who is the student in this class, who's teaching this student. Okay? And then, for example, you're just getting data of Rebootkamp, and if you select only C.name, which is class.name, you just get the classes of, and you can get the classes of Rebootkamp, and you can also get the teacher who's teaching Rebootkamp. All the tools are there. Just use them.
What if, can I say, what if like Rebecca and Kelly is not teaching Rebecca? What will happen in this situation?
Yeah, it will give you just empty, yes. Correct.
This is how you make query.
That's called a query, yes.
We have
That's
to
a
do
query.
JavaScript or
No, that's SQL.
no, I mean, we don't have to organize JavaScript. Yes.
On it is. It's a new thing, new language.
Just practicing this.
Yes, again, guys, very important, understand. The first one is called school, SQOL. That's visualizing, like you interact with the repo. And the other one, but you should finish it one by one. You should, it's like, you cannot skip any of them. And then the next one is using MySQL to do something else that's relating to the app.
You should play on the school. Do the
Finish school as soon as you can, but learn. Very important to learn. Practice and learn. Focus on it. And then you can go to the other exercise called databases. I think there are two classes there, right? The first one called school, which is this one. No. Is it this one?
This is the second one.
That's database. That's school. Production school tells you what to do and will go through some queries. What does it mean and how to do it, and ask you to do stuff like this, right? It should be easy after this long lecture. I spent energy here, guys. Like, don't. Okay.
We appreciate it.
And then, yeah, that's fine. And then it will ask you to do some like install it in your like MySQL server, in your computer. And here where, let me just show you something. Yeah, here where like you can like see the create and update of the tables of the database. Yeah, and then the next part is after you create this database in your computer. I mean, you already tried selecting stuff, but now you're creating this database and you link it to your chatterbox. The chatterbox already had SQL database, not SQL, a database. Now your job is to link this new database you created to the chatterbox.
Is the next sprint?
No, it's one sprint.
Set
Then
the box-
tomorrow.
The chatterbox
Tomorrow there is only tomorrow, yeah. I have one for you. It's not databases. Something really fun called How the Internet Works.
That's a really long lecture. I saw it.
You will love it. Okay guys, yeah.
If you're using the term, is there a do button? If we did something like, George did something incorrect?
No mistakes allowed. If you delete a file, it does not go to trash. It goes forever. Yeah.
You have to
Be
download
careful.
the report.
It's for adults.
Thank you, Ahmed.
Thank you guys. Please, I would really love to get some feedback because this is my first sprint. I want to know what's your impression about it. So to learn for next time. So please give me very constructive feedback.
Don't worry.
And Jose, I won't stop you guys about something funny.
Another lecture.
What? No, they're tired.
No, I'm kidding. I want to tell them about the.
Okay, tell them.
Morning.
You are in the
Fine.
recording, by the way.